So first, I'd like to welcome Chris Miller. Chris is with Beta Technologies. Chris helps prepare airports for the future aircraft landing by leading the Charge Network business development effort on the West Coast. He's been at Beta for over 2 years, where he has project managed the installation of over 22 charger stations in 14 states across the United States. Additionally, he was on the project team that successfully installed the first electric aircraft charger on a Department of Defense base in the world. Chris works with airports, the FAA, FBOs, and other government agencies to help the growth of electric aviation. Chris considers himself an airport nerd and holds his private pilot license. In his professional career, he has engineered and built just about everything you can find on an airport in several states. Outside of flying around, he enjoys sailing and golfing. So welcome, Chris. Our second guest is Scott Shelto. Scott is with McFarland Johnson, and he is a specialist in the transition to e-mobility, particularly at airports. Scott has been asked to speak on these topics at events like the annual American Association of Airport Executives Conference. He has been instrumental in forming McFarland Johnson's e-mobility practice. Scott's the project manager on Beta Technologies projects, where he has assisted Beta in installing their AAM chargers at over 15 airfields, with several more on the way. Scott's also been acting as the program manager for Avis Budget's electric charging station program at airports projects, which to date has installed EVSE at over 100 different airports nationwide. Scott also has 12 years of experience in the design and inspection of aviation projects at both commercial and general aviation facilities. He has assisted on numerous airport design and planning projects. So welcome to both of you. I am going to hand it over to our first presenter, Chris.
Thank you, Jackson. Really appreciate the intro. Hello, all. Let me share my screen real quick and we'll get started. So, as Jackson said, my name's Chris Miller. Work for Beta Technologies. I work on the West Coast network development for Beta, and super excited to be here presenting to you all. Really happy to share who Beta is, what we're doing, why we are so amazing and awesome, and how we can help Minnesota really advance the AAM market. So one caveat I want to say in this presentation is Beta is really big about do it, don't just show it. So all images in the slide deck, all photos, anything here, they're not renderings. These are actual photos of our aircraft actually flying. We don't do Photoshop, we don't do renderings, we don't do any of that. So if you see something, this is our first production aircraft here in this first photo, actually flying on making its way out west a few weeks ago. So I wanted to start off with economics of electric aviation and why we think that it's really going to be a nice additive to the aviation market. And that is the first is this photo was taken from one of our chaser planes, so we're able to really get a nice one-to-one comparison of the cost of what it costs to operate a traditional Jet A fuel aircraft to what our aircraft, as you see flying in the photo, is. And because of that, we think it's going to be about 40 times cheaper than the current combustion engine aircraft from an energy perspective. And then there's the maintenance perspective, which is there's the only fuel lines on this entire aircraft are the brake lines. Everything else is all fly-by-wire, and it's all air-cooled, and it's all magnets, so there's no really grinding parts. So your maintenance then, your overhauls, your annuals, your oil changes, all of that, right, disappear, or you need longer durations between. So we think it's going to be about one-third the cost than a traditional comparative aircraft. And then I already touched on this, where we have about 70% fewer parts than the traditional aircraft. So you're not replacing parts as frequently. They're not wearing out. And so you're saving quite a bit of cost there. So I will start off with a quick video. I'm gonna hop over here.
Nice to meet you. We're Beta, and we're an electric aerospace company.
We are pilots.
We are data scientists.
We are VTOL.
I'm an
I'm
engineer.
AMP,
Project manager.
former Marine, engineering for batteries.
I came from the
I
FAA.
came from the National Test Pilot School. Recovering lawyer, mechanic.
We came from Vermont and we are building electric airplanes. All forms of transportation are going electric, and aviation is next. It's better for the environment and costs less to fly. When Kyle met Martine Rothblatt, a friendship formed around a few simple philosophies. Following first principles engineering, working hard to find simplicity in designs, and building a team of people who are creative, passionate about their work, and authentically themselves. Martine told us she wanted an aircraft with a 50-foot wingspan that could take off and land vertically and perform reliably to carry supercritical medical cargo. So we built Aaliyah. We tested it in the cold, we tested it at night, we flew it vertically. Martine flew it. Fast forward a few years, we have multiple aircraft and multiple customers.
We're very excited about the partnership we have with Beta Technology.
Our charge network has expanded across the East Coast. The bigger our network gets, the more fuel we can eliminate from package delivery. And that's a good thing. Our motors have quadrupled in power density since we started making them a few years ago. From the early days of building Ava, we learned we are made stronger by the company we keep. We've expanded with that mindset to make the transition from a research and development company to a production company.
Sir.
Our production facility is net zero. We generate all the energy that we use to power our assembly lines.
Goes taking runway 35 at Alpha.
We're building a green aircraft in a green production facility in the Green Mountain State. We got here by learning from our mistakes, sticking to our mission, and keeping our promises. And that's what's going to get us to the finish line. We're an electric aerospace company, a collection of people who know that really hardworking, committed folks can change the world. And we've got more work to do.
So hopefully that gives you a little bit of background into kind of the culture of Beta and who we are and what we stand for. And that's the production facility, as mentioned in the video. It's completely green. It's net zero. We generate all the energy we need, and we handle all the waste on site. But Beta is we're an aerospace company. We're up in Burlington, Vermont. In case you don't know us, we were founded back in 2017. We are currently about 750 people, and we're still completely privately held. So this is a great photo I kind of like to share of our aircraft flying the Hudson Corridor. For all of you who don't know, it's really cool with Freedom Tower in the background. But there's kind of three different arms of Beta. And there's the electric aircraft, as you can see in the photo. That's the pretty part of Beta. It's the part everyone loves and cares about. But if you have a bunch of electric aircraft flying around, right, you need that charging infrastructure to really help charge it and create a network where these aircraft are usable and can do some meaningful work to deliver packages and people. And we fully realize that this is another type of aircraft that's going to be out there. And so we have a complete training program that is training the next generation of pilots to be able to fly these type of aircraft. So we have, as you can see on the screen, these are some of our partners. And the only way that you get on the screen is if you've actually put money, or you've actually committed, or you have actually installed charging network or bought an aircraft. So we're pretty proud of the screen. There's some probably notable companies on the screen that plan on operating our aircraft. So we have two different types of aircraft. On the left is the Aaliyah VTOL, A250 is what we call it. It's the vertical takeoff and landing aircraft. So it takes off like a helicopter or a drone, the pusher motor engages. You have a runway in the sky. Once you're fully on the wing, you disengage those top rotors. Now you're flying just like a plane. And then to land, you turn those top rotors on, turn the pusher motor off, land. You get the conveniency of a helicopter, but the economics and efficiency of a plane. And so you really opens up a lot of opportunities out there that were previously not capable. And then we have our AAM CTOL, which is CX-300, as you can see on the right. And that exact plane is out currently flying right now down in the southern part of the United States where it's warm and sunny. But that aircraft just got done flying from Vermont all the way out to Santa Monica, and now it's on its way back to the East Coast before it heads back up to Vermont on a very lengthy and well-deserving road show. And the reason we have these two models is the path to certification, where Beta is taking a crawl, walk, run approach. And so we're not just jumping to that VTOL for certification. We're going to start with our motor and actually certify that. That'll be certified this year. And then once we have our motor, it can be completely agnostic of any aircraft, including our own. So if we go put it on another aircraft and, the normal combustion engine is about 33% efficient at turning energy into propulsion. The reason it's that is because it only has to be because your energy density is that much greater with traditional fossil fuels, right? The problem with electric, right, is you have to flip that because your energy density is not as dense. You have to have a really super efficient motor. So our motor is about 98% efficient at turning energy into propulsion. And so it's a super efficient, super high-powered motor that we really believe has a lot of potential. So once we have that certified, then we'll be able to certify our CTOL. And once we have our CTOL certified, we'll certify our VTOL. And there's a 80% commonality between the CTOL and the VTOL, meaning once we have that CTOL certification, we'll only have to certify 20% of the airframe. And by then, we'll have a bunch of really awesome and great test data from the CTOLs flying around that we'll be able to use in helping that certification. So these are some notable milestones that have recently happened. I'll touch point on the high ones, which is we've just flew, I kind of already touched on it, but 916 Lima Foxtrot just flew from Vermont all the way out to Santa Monica, which is literal coast-to-coast flight, completely on our own charging network. And on the airports and in areas where we don't have a charging network, we were able to charge in hangars or with a charge truck. And now it's on its way down to the Gulf Coast. And then once it stops in the Gulf Coast, it'll make its way back to Vermont, kind of doing an all-encompassing circle of the entire U.S. So now I'm going to touch base on the charge side, which is the side that I work on, and the side that I'm hoping we can help Minnesota prep for with these electric aircraft and AAM aircraft coming here soon. So this is our charge cube. It's the first EV charger designed by pilots, built for aircraft, with everything built for pilots to be able to plug in. We were using traditional EV chargers, and what we realized is they're really, really good at charging outside of the fence, or landside as we all call it, but they're not really great charging inside the fence, and they weren't designed to charge aircraft. The cord's not long enough. Airplanes have this thing called wings, right? And typically those chargers are pretty tall, so you can't get the wing over the charger. So we went out, we designed our own charger, and that's what you see on the screen here. We call it the Charge Cube, and yes, it is a perfect cube, in case you're wondering. But it's a 320 kW charger. It has a 50-foot retractable cord that's pay in, pay out on a reel. So you just push two buttons, and it reels it out, and it reels it back in on its own, so you don't have to pull the heavy cord anymore. Which, as far as I know, Scott may correct me, but this is the longest cord of any EV charger on the market right now, landside or airside. So we're pretty proud of that. It's the CCS1 standard, meaning it's completely multimodal. It could charge your F-150. It could charge your Tesla. It could charge ground service vehicles, trucks, our aircraft, other aircraft. And from 0 to 100, you're looking at sub 50 minutes. The thing about aviation, right, is everything's mission based. Rarely do pilots hop in an aircraft and go, I'm just going to fly this aircraft until I have zero fuel and then find an airport to land, right? Typically, you do all of your flight planning, your fuel requirements, all of that on the ground, and you charge your plane up to exactly the amount of charge that you need. So you're going to know how much charge you need to get to where you're going, plus reserves, right? So it could even be, you're not going to land with zero. You're going to land with some type of reserve. So your charging time is probably, we think, is going to be 20 to 30 minutes. So by the time you get out of the plane, go into the building, flight prep, grab a snack and a water, your plane's probably going to be done charging. So this is kind of the long-term vision with AAM charging. And that is, right now, we're just installing that middle cube, the vehicle charging cube, the one I just talked about. But in traditional EVs right now, for those of you on Teslas or F-150s or any other type, your battery conditioning is actually riding along in the vehicle with you. The most important thing with aircraft is weight. Weight is not your friend in an aircraft, right? You want that aircraft to be as light as possible. So with aircraft, we have to leave that battery conditioning on the ground. So what that means is we're going to have a completely separate cube. We'll pump the glycol into the battery. We'll actually condition it while charging for optimal charging on the ground. And then we'll take that fluid out of the battery, leave it on the ground, and you'll go fly the aircraft. And that's the battery, the cube you see on the right-hand side of the screen. And then long term, just like traditional jets do today, you actually have a cabin heating and cooling. So while you're charging on those cold Minnesota days, you'll be able to pump heat into the cabin. So when you walk out to your aircraft and you hop in, it's not freezing cold. It's nice and heated up for you, and you can just return it and return the hose and be on your way very comfortably.
Hey, Chris, we do have a question here for you.
Sure.
What is the distance or time range for one charge?
Yeah, no, great question. So in our CTOL model right now, it's about 300 nautical miles. And then in our Alita VTOL is about 250 nautical miles. So, and that's as the crow flies. Really, it's going to be more your traditional aircraft right now operate on gallons per hour, but that doesn't really make sense with an electric aircraft. So it's really going to be on your kilowatt hours and your kilowatts you're currently using. So if you're super efficient with your power and your throttle, you'll be able to extend that range and really fly efficiently and get the most out of the battery. So yeah, hopefully that answered your question. Thanks for the question. So this is our mini cube, and it's the hangar version of our cube. Basically, it's not outdoor rated. This is for if you are going to hangar the plane overnight. It's a little bit of a slower charge, but you'll be able to pull the plane into the hangar, plug it in, let it sit for about 6 to 8 hours while it charges that battery. It's a 40 kilowatt model. It's about a 50-foot cord reel still, but it's still technically, as far as a EV charger goes, classified as a level 3. And it still has the CCS1 completely multimodal and awesome little wheels. At our Christmas party, we did empty the hollow one out and turn it into a cooler, which I think is pretty cool. So I kind of touched base on this already, but essentially, our chargers are completely multimodal. You know, as Joe with Minnesota DOT will probably tell you, you know, and the FAA, you know, what's good for one in the aviation industry is typically good for all, right? And so we believe on helping this whole industry grow and succeed. So this is completely multimodal, completely agnostic of the beta plane. This doesn't just charge our plane; it will charge, you know, all things electric on an airport, and really helps us stand out as kind of the leader in charging on an airport. And it uses the CCS1 standard. So, as I mentioned, you can charge that ops vehicle, you can charge the bus, you can charge all that. And it's all done through our app. We have an awesome digital services team sitting up in Vermont that manages all of this. I've had the privilege to download almost every single EV charging app out there, and I can confidently say that ours is the most user-friendly. It's just 2 buttons once you do it, and you're charging. So it's a great user experience. And this is something that is really great and exciting, in my opinion, which is just the industry alignment in the AAM. There was a Gamma white paper that was published, and pretty much every single OEM in this AAM space has all aligned around the CCS1 standard for charging. And we work with pretty much every single person listed on the screen to align around the charging standard and the future of charging and how we're going to accomplish this together. And so all of these companies on here are planning on using our charging or can use our charger. And this is our current charge network right now. All of those circles that you see with a little lightning bolt are up operational. The empty circles are ones that Scott and team are helping us get built in the process right now, and we're making our way not only up to Minnesota here soon. So you know, this is real life performance. I kind of, you know, already touched on this, but essentially these are some high level milestones that we like to brag about, which is that we fly our plane all the way around, we charge it up. We did some flight training with the Department of Defense down in the southern area of the US, and we have 46 charger locations commissioned right now, with another 20 in the pipeline that Scott will help you help us all learn on how to get those actually installed. And so now I'll actually hand it over to Scott. This is what one of these chargers actually looks like at one of our airports, but I'll turn it over to Scott to actually explain on how we walk you through the process of how we get one of these actually installed on an airport.
Awesome. All right, thanks, Chris. I appreciate it. Let me get my screen up here and share that. And get this up. All right. Hope you all can see my screen. It looks like you can. So as Jackson mentioned, I'm Scott Shelto, National E-Mobility Lead for McFarland Johnson. And thanks, Joe and Jackson, for having me speak here today. As Jackson mentioned, I'm a civil engineer by education, aviation engineer by practice, and have transitioned into this e-mobility role over the past couple of years, installing lots and lots of chargers nationwide, helping Beta, helping Avis, helping airports understand electrification, and getting some physical chargers on the ground. You know, that's really what I do. A little bit of planning and whatnot, but the actual implementation of the chargers is kind of my thing. So these are the things I'm going to hit on. We're going to start with site selection, go into FAA approval, infrastructure, and then I'm going to provide some examples that we can walk through. So site selection. The first things first is origin and destination. And I don't want you to think of origin and destination just in the macro, but also think of it in the micro. You've already selected the airfield. You already know that it's a good origin or destination for AAM. But then where on the airfield does it make sense? So as Chris mentioned, the aircraft has a mission. So understand what that mission is of the aircraft. Understand where your cargo is going to go if that's the mission of it. Understand where your pilot and passengers are going to go. And in particular, always keep that pilot's use in mind, right? Because if the aircraft has to land and charge, that pilot needs to go somewhere. So pilot lounge, etc. Especially if they're there for an extended duration. So always have that idea when you're considering where to put these chargers. You don't want to have the pilot go to the terminal, drop the passengers off, and then taxi all the way across the airfield to charge, and then that pilot's kind of on an island on that other side of the airfield. Maybe they can't get to the pilot lounge in the terminal or the FBO, wherever that may be. So always kind of have that, be thinking of that micro origin and destination as far as siting these chargers. Next is look at your ALP. And the first thing you're going to want to consider is those future build-outs, right? Understand where future construction is. This may save you headaches in the long run. Maybe you have an apron or extension of a taxiway. If you're a planner, you always consider this stuff very flat. So I just mentioned this, but consider those grade changes. If you are extending a taxiway off an apron and it's a good spot for a charger, you may have a significant grade change there, which could affect, how that charger sits. So if that project's planned within a couple of years, you kind of want to understand that and take that into consideration when you're siting these chargers. Avoid areas with potential airspace restriction. I mean, that's kind of obvious. That'll get flagged in your 7460, which we'll talk about later. But just something to consider when you're putting these in. If they're close to the end of a runway or something, you could have some airspace restrictions that you just don't want to mess with. So keep it well away of that. And then another thing per NEC is 25 feet away from flammable fuel or gas emissions. So don't just think about your aircraft Jet A or avgas locations, but also natural gas, anything like that coming into a building. You need to have a 25-foot separation. And that's per NEC. Your AHJ and fire marshal may go above and beyond that. I've had some say 50 feet, had others come back and say 100 feet. It all varies, and it's something that you can work with your permitting agent on to really understand what's going to make them feel safe, and you can work within that. And again, that's from the end of the cord to where that flammable gas is coming out. So, if you have that 50-foot cord for the beta charger, imagine that fully extended and then a 25-foot separation. So another thing to consider is parking aircraft for extended durations, right? Can you put an aircraft here for extended durations? Maybe you're looking at an area that has existing tie downs. Well, also consider, are those tie downs in long lease agreements already? That may be a no-go if, the airport's getting paid out for these tie downs that are already reserved. And finally, if you're getting really tight on space, just look at the CIP, right? A lot of stuff shown on the ALP may never get built, and you may even get a usable life out of this charger by time these CIP projects or these future development projects come into play. So maybe you have a terminal expansion and you have a really good location right next to the terminal, but that area is going to be claimed for your terminal expansion in the future. Well, you may get 10 years out of this charger, and great, you got a useful life out of it. And it can be shifted in the future during that terminal expansion project. So all stuff to kind of just be rolling around in your head, and it will give you, a couple of good areas on the airfield when you're looking at the ALP and understanding that origin destination. Next thing you're going to want to consider is power, right? Very, very critical. You need to have power to charge these. It's simple, but 480 volt, 3-phase within the vicinity. The further we get away from that, the more difficult or the more expensive your install is going to be. I mean, you don't want to, there's some general rules of thumbs you can consider, be within 700 feet, et cetera, depending on your funding source. But The further we get away from that, the more expensive it is, and just stuff that could be easily avoided by doing a little bit of research. Best way to look into that, review as-built. If you have overhead poles, is there three-phase on the wire? I mean, that won't guarantee it's 483 phase, but it's an indicator. Look at existing transformers within the vicinity. If you don't have any record information, they'll have tags on them that say 480 volt three-phase. So those are just a couple of indicators that you can look at. And also consider where you're going to put those transformer and support pads, right? It's not just a charger. You have these pieces of support equipment that go along with that charger. And then aircraft movement, something that can be overlooked, but very critical. You're looking at a 50-foot wingspan, 80 G2. This aircraft needs to get in to that charger and get out of that charger. This example that I'm showing here was a charger that was sited, but after some further review, you have limits because the tie downs are sited for 80 G1. So all things to really look at when you're trying to site this charger on an airfield. Those tie downs may have to be shifted and relocated. Engineering brief 105A also has some guidance on this too. On an apron space, they say 10 feet between the end of the wing and a fixed or movable object. So also something to kind of consider when you're pulling your aircraft up to that charger. Plan for that 10 feet of space. It doesn't always happen in actuality, but, make sure you can, with a straight face, say that you have that clearance. So you kind of have your site selected. You've figured out where this charger should go. What do we have to do for the FAA? First things first is Section 163 is now Section 743 under the FAA Reauthorization Act, which is great. If you ever worked in Section 163, I always thought it was backwards, right? You did an ALP update, and then you pulled all the deeds and land use maps, gave it to FAA, and then FAA said, yeah, you need an ALP update. But now with Section 743, because it's a charger for an aeronautical use, an ALP update is going to be required. Because an ALP update is going to be required, it's going to trigger your NEPA. And, that is regardless of funding. So so start coordinating with your FAA ADL on that Section 743. Just let them know you have a plan for a project that's not shown on the ALP and, start that process with them early. So ALP update, as I mentioned, your Section 43 will dictate that. It's going to be required. I haven't seen a situation where my ADO has come back and said, nope, you don't need this. Do your ALP pending change. A lot of times we're doing those in CAD, right? So get your signatures back on them again. But if you're just doing a traditional ALP update with an already signed ALP, you may not need to do that. Just, again, coordinate that with your ADO. And then NEPA. All the projects I have done have been just a documented CADX. Never had to do an EA on it. So it's pretty simple. Just do your documented CADX. Each ADO is different as far as what they require on them. Some are more difficult than others. I used to have one person up in New England who would do emailed CADXs, which was great. He's no longer with the FAA. He retired. He had some pull, I think, but that was incredible when we used to just get those emails. And then finally is your airspace. So submit your obstruction evaluation, your airport airspace analysis. These are just your 7460s. Do them all the time. Make sure to submit for your permanent and your temporary equipment that's going to be used to install. And then make sure to follow your determination. I know that's something that gets some people, but sometimes read your determination. Make sure there's nothing in there that says you have to do this as well or consider this, etc. So always read those. No, don't just take it for face value. All right, so infrastructure. First thing, charging infrastructure, and Chris mentioned this a little bit, and I just want to reiterate. You're of course going to have your AAM charge cube, right? That's going to be your base. But are you going to plan for that battery conditioning? Are you going to plan for that cabin conditioning? Where are you going to put your support equipment within the vicinity? Are you going to have a landside charger? Engineering Brief 105A expands on this a little bit, and they're going to refer you to NFPA 70 and NFPA 418. 70 is for electric vehicle charging. NFPA 418 is for your vertiports, I think. I don't have that exactly memorized, but I believe that's what it is. So just review those as you're going through them. Putting conduit in the ground is cheap. Making this capable is cheap. Coming back and doing it in the future is expensive. So I would always plan for the future, put that extra conduit in, make sure you leave yourself a couple extra breakers on your distribution gear as you're planning a design. So this is your inverter to your charge cube, right? So you have AC power coming in, goes to an inverter, DC power coming out. That inverter needs to be within 250 feet of that charge cube. And then that charge cube 50 feet to your aircraft, right? Because that's your cord length. And really you want a little closer than that because you don't want to be at the end of your cord length. You kind of want to split that difference, but still keep in mind Engineering Brief 105A, which says 10 feet from the end of a wing to a fixed or movable object. So you kind of have your range when you're sighting it. These are some numbers. I feel like this will be useful to the engineers out there who are doing some planning. You have your beta inverter power tower and charge cube, which draws 350 kVA, beta cabin conditioning, 17 kVA, and beta thermal management cube, which is 67 kVA. The beta inverter tower and charge cube doesn't have a continuous load factor applied to it. So keep that in mind. That would fall under your NFPA 70. So you need to multiply that by 1.25 if you're planning for that future load. But just kind of wanted to show you some raw numbers. So you're sitting around 434 kVA with no safety factor. You'll be over 500 once you apply that safety factor. So you can kind of figure out what size transformers you're going to be needing. And this is just a simple one line. This also good if you're trying to reference something, but this anticipates a landside, and actually if you can see my cursor, it anticipates a landside DC-FC charger in here. So this equipment's a little bit oversized depending on what you want to do. But if you do want a landside DC-FC, this is kind of a good reference sample one line for you. And again, this also considers spares for your battery conditioning and your cabin conditioning system. And then I just showed this is a landside level 2 that we've installed at projects as well. So civil infrastructure, really not a ton involved on the civil aspects, but again, you're going to need equipment support pads to support your equipment, your housekeeping pads. Again, reference Engineering Brief 105A, consider your wingtip clearances, you're an ADG2. If you need to add additional apron, the max takeoff weight of the Beta Elia is 7,000 pounds. EB 105A recommends you use 12.5. So all stuff to consider. And then I make a note down here. They make no recommendation on bituminous design for an apron, but they do make a recommendation for PCC for your FADOs and your TLOs. Oops, excuse me one second. And next is your utility. All of the designs we've done have had a dedicated utility transformer, dedicated meter. So your transformer size will vary depending on your future proofing and your landside charging, but you're going to be somewhere in between a 500 kilowatt if you're not planning for battery conditioning and cabin conditioning, or up to 1,500 depending on what you want for landside vehicle charging. Good assumption if you're just at a planning level is 1,000. This will get you the Beta Cube, cabin, battery conditioner, and a landside DCFC. So if you're at a planning level, 1,000 kilowatts is a good reference point. Coordinate with your utility early and often, though. Utilities all like to deal with real numbers, and they may not provide you any information if reinforcements are required until you submit that utility request. So I recommend getting that in early and coordinating with them as soon as you can, because what you don't want to happen is You don't want them to come back and say, hey, we need to reinforce this area. It's going to be 700,000, right? That could kill a project pretty quickly. So get that in and get that coordinated as soon as you can. And it avoids going from this to this a lot quicker. And then construction, just buzz over this quickly, but typically construction process is about 60 days, give or take, depending on the complexity of the project. Make sure to have your phasing and construction plans. I avoid saying CSPP in this specifically, depending on your funding source, just because you may not need a true CSPP, but if you are receiving AIP, you will need that phasing construction plan. And then some examples. So starting with Nantucket Memorial Airport, this is a site we're looking at currently. Nantucket is a seasonal airport off the coast of Massachusetts, and this airfield will be jam-packed with airplanes in about every piece of open pavement between Memorial Day and Labor Day. It's a very, very busy airport in the summer. Has a lot of operations. So when we first start looking at this airfield, and you're trying to site a charger, in my opinion, you're kind of looking at anywhere that is, feasible to the FBO, which is here, or the terminal that is here. So you kind of have, all of this area probably. But then you start really, drilling down on that. Where is your 480? Where are your future build outs? Those are as we talked about at the first couple of slides. And originally we were kind of thinking, hey, over in this area would be good. But you have these planes parked here. It's good space for long-term leases. And your 480 is actually kind of ends somewhere over here. So it would be a little bit of a longer run. So that kind of cuts out that area. Then on this side, you have your scheduled aircraft all parking in here. So it really kind of eliminates everything within that red box there as well. So what we decided on was actually a great location. It's right next to the FBO. The FBO is just in the back here. Actually, if you see on this photo, it's right here. This is the FBO. Right next to it, we could get a charge cube in. We could get that support equipment in. And 483 three-phase is just off the screen. It's just up to the top here. So, a really good location. It checks a lot of boxes, and a good place for the installation of a charge cube. Next is Republic. This is on Long Island Executive Airport. Kind of another cool situation. They came to us and said, hey, we really want to get the charger out here. Where can we put it? And first thing we asked them is, okay, where do you have power coming in? He said, well, next to Republic here, we have our transformer right here. So the first thought was actually right on this right-hand side next to this main apron. Great place for dropping off passengers. Pilot's got a location. All of that stuff is checked off. However, and I don't even know if it's shown on this ALP because I believe it's old, but they said, we also have a planned apron expansion in the near term coming this way. So, right, that's gone. So we came back and we said, okay, well, what do you know about the three-phase? How does that run around the airfield? And what they told us is around that main entrance, three-phase is run the whole way, 483 phase. So we're like, great. What else do you know about it? Well, they said, well, we actually removed a primary recently back to the street, so we know where there is a recent connection, or we recently know where that 483 phase was dug up. So I was like, oh, even better. So what we came up with off of that was putting it in this corner, and we show it here. And this was a conceptual. We're actually moving it up to this corner. The problem with this location is they have international flights, and they have the G650s and A320s coming in and out. And what they wanted us to look at is, can that aircraft come in and the ALIA come in, and can a G650 come out? And yep, we can do that. We talked with the FAA and the ADO about it as well, and they said, yeah, that's no problem as long as the pilot's not in that location as the international flight's offloading as well. So that was kind of the location that was settled on. They will have to do some fence removal and relocation, but again, that wasn't a big concern of theirs. So again, another good location for this charger. And then Syracuse. I like the Syracuse example because in their ALP, they identified FATOs for the future. They have them all across the airfield. And they came to us and they said, hey, we want to go in for a grant. What can we do in the short term to get some AAM charging out there, but still have that long-term vision in mind? And so we started analyzing the available power around the airfield. This is pulled from National Grid. They have their GIS information available with their available headroom. And we started checking off some boxes on, hey, where's their power? How could we get a charger out there? What can we do in the short term for cheap money? And we came up with a short term and a long term plan for them. And it basically expanded on, you could get a couple chargers out here on, your existing ramp, be ready for your ramp extension, and keep your distribution gear centrally located where you could then do, secondary charger if you're ever going to install the FATO. So very cool little potential project coming out of that. And here you can kind of see the overall picture. Chargers on one side, chargers on another, future build out of the FATO and everything else. And we're at 10:50, so I think we did a perfect timing because that'll wrap up my presentation.
Great. Well, thank you, Chris and Scott. To everybody, if you have any questions to ask, now is the time. Looking at the Q&A, I don't see any at this moment.
I can start with a question, Jackson, while folks take some time to digest. Let me just first start off by saying I think that this is probably one of the most comprehensive looks into how electric aircraft charging infrastructure has been installed in airports. So really appreciate that, Chris and Scott, for sharing that. Super helpful. I think for all the folks on the line here. Maybe my first question is, on that distance from fuel farm requirement, Scott, you said 25 feet. It kind of varies from by the local authority. Is that in that NFPA code that you shared that is referenced at like the local level, or where should we look to find that information?
Your 25 feet is NEC, so that's National Electric Code, but also yes, it's an NFPA 70. They're kind of all one world. But yes, that 25-foot separation is per NFPA 70. But your AHJ may have further requirements. So that is probably by county where you guys are. So you'd want to talk to each fire marshal and understand what they're looking for. Because that can get you. And again, if you're thinking about a fuel farm, you're gonna have to think about extending that fuel nozzle as far as you can and extending that 50-foot beta cube, and it's 25 foot between those ends. Per code, each authority will translate that different, but that's the way it's been explained to me a few times.
Yeah, Joe, at Beta, we have a standard best practices of minimum 50 feet from anything, which, in talking it out, 50 feet seems like a lot. If you go out in the real world on an airport, 50 feet, you're like, wow, this is really close, so.
Okay, that's great. Jackson, looks like we got a question that came in as well.
Yep, there's a question here. How hard is the pilot transition between your electric aircraft versus traditional aircraft?
Yeah, great question. So our aircraft is a little bit unconventional in that your yaw is no longer controlled with your foot pedals. your yaw, your pitch, and your roll are all in the hand. And so it's completely fly by wire. And it would take a private. We're the only credentials you need to fly our CTOL are private pilot and single engine and high performance. And then it would take a private pilot roughly 8 to 10 hours to get comfortable flying in our aircraft.
One thing I mentioned there before we move to our next question on the Q&A is the beta aircraft is on X-Plane 12. And so if you're into flight simulation at all, you can fly the ALIA 250 in X-Plane. I know there's some other AAM aircraft in X-Plane and Microsoft Flight Sim, so it's just plug there.
It's really fun. You should go. We should all go fly X-Plane after this. So yeah.
All right, Chris or Scott, could you tell us the cost of a typical charger installation?
Yeah, Scott, you want me to, or do you want to?
Yeah, Chris, why don't you go for it?
Yeah, so full white glove where you go to Scott and I and you say, I want to walk here 6 months from now and I just have a charger. You're probably looking at around conservatively $800,000. And that's obviously based on construction costs. I don't know if Minnesota's higher construction costs or lower, but the national average. But it's also Scott did an absolutely incredible job of pointing out where you put it on the airport dictates a lot of the cost. You know, if you're super far from three phase, or you have to bore under some pavement, your construction costs go way up, right? I mean, we've had sites just construction be as cheap as 150,000, and we've had them as expensive as 400,000. So where you place it, the closer all your equipment can be, and the more edge, more like access to the land side through grass it can be, the cheaper typically your installation overall is going to be. But yeah, conservatively on the high end, 800. We've seen them as low as around 500. I think our average between all our sites is hitting right around 600 right now. So,
And Chris, to reiterate, that's a total cost, right? Equipment, installation, planning, design, construction.
yep, absolutely.
Yeah.
And Joe, if you're planning for the future, one thing that doesn't have great numbers on is your prevailing wage and any of those other requirements, because that was coming from private funding source. So it's not a public bid, AIP, prevailing, that kind of stuff. So, add a factor of safety on that just to make sure you are covering yourself.
Scott, appreciate that.
Okay, awesome. Looks like we have another question here. Has Beta been working with the FAA on fire suppression concerns as it relates to ARF?
Yes, we have. We have an entire battery testing facility up in Vermont, and we continue. We talk to the FAA. Every department of Beta probably talks to the FAA every single day. So we have taken the approach where we want the FAA to be our best friend. We don't really see them as a hurdle, but as a way to, like, hey, help us make this happen. So yes, we are actively working on that.
Maybe a follow-up question for that for Scott or Chris is, as you're talking about siting a charger at an airport and going through some of the preliminary engineering and construction, are you engaging local emergency response? Any lessons learned or key points on that engagement?
Yes, so we typically leave it to what we have found is every ARF is it's the classic joke of you've seen one airport, right? And the ARFs are no exception to that. And we are not first responders, right? So we've actually left it to the local ARF and their training, right? And they're going through massive EV training all the time as more and more vehicles are being electrified. And it's actually been a kind of a breath of fresh air where they're actually educating us and actually telling us on how they're fighting EV fires. So
Yeah, and just to add to that too, each R for AHJ are going to have different things they want to see, different types of disconnects, whether that be Knox box disconnects or emergency shutoff switches. Each of them are going to have a different opinion on it, and none of them are wrong. So it's really just working with each one to make sure they're getting what they want in case of emergency.
Well, I think that one goes to the end of time.
So sorry, Joe, you're a little mumbled there.
Sorry, I said I think that runs us to the end of our scheduled webinar time.
Yep. Okay, great. Thanks for repeating yourself there. I am just going to share one last thing on my screen here. To those of you who are still tuned in, we would ask you to please take a minute or two out of your time to complete an evaluation. Just tell us what you thought about today's webinar. I also did put a link in the chat there that helps for planning future webinars. So please take a minute. Thank you.
Yeah,
And thank you
Jackson,
to,
one last thing, if you
sure.
don't mind. So thank you all for organizing this and letting me talk, and hopefully you learn a little bit more about beta. We have please don't hesitate to reach out, any of you, if you have any questions about beta or you're interested in putting a charter at your facility, please feel free to reach out. We could definitely happy to answer questions, and beta has a complete open door policy. So if you ever want to make your way up to Burlington, Vermont, just give me a heads up. I'll meet you up there. We'll give you the full tour of the factory, show you how the plane's made, charter's made, all that good stuff. But thank you so much, Jackson and Joe, for having me on here. Really appreciate it.
Yeah,
Thank you,
thank you
Chris, and thank
to
you, Scott,
Chris
as
and
well.
Scott,
Both of you guys have been great.
and to everybody else. Thank you for joining us today. Enjoy the rest of your week.